Hey guys, welcome to lesson 2.8, determinant applications. So we are going to learn how to do two things. Find the area of a triangle using a determinant, which is going to be a 3 by 3, and use Cramer's rule to solve systems of equations using a 2 by 2. So for the 3 by 3, finding the area of a triangle is pretty easy if you know how long each side is. But if you only know the coordinates of the vertices like this or this, then it's actually kind of difficult. Let's go ahead and do that. And then we're going to basically make a matrix out of the 3 points. So this is a point, this is a point, and this is a point. And then because you can only take the determinant of a square matrix, we need a third column since that makes 3 rows, one for each point. So we're going to make a row or a column of all ones here at the end. And just like we do 1/2 base times height, we're going to do 1/2 times the determinant of this. This ends up being kind of like the base times height. This weird thing out front means that you're either going to use positive 1/2 or negative 1/2. Basically, just use whichever sign makes the area positive. Okay, because you can't have a negative area. So if your determinant ends up being positive, multiply by positive 1/2 to keep it positive. If your determinant ends up being negative, multiply it by negative 1/2 to make it positive. Okay, so we're just going to kind of start in on one. Finding the determinant is what we talked about last time. Really, you just have to set it up and then do exactly what we did in 2.7 and multiply it by 1/2 or negative 1/2. So first thing we need to do is decide what the points are. So this one is over 1 up 6, so that'd be 1, 6. This one is over 7 up 1, so that would be 7, 1. And this one is over 3 down 1, so that would be 3, negative 1. And then basically you just make that into a matrix, and we're either going to multiply it by positive or negative 1/2. We have the point 1, 6, 7, 1, and 3, negative 1. And then add your column of all ones at the end. Then, to find the determinant, like we did in 2.7, you're going to copy the first column, and then you're going to copy the second column so that you can write your diagonals. Right, so when we're finding the determinant, what we do is we do all the diagonals that go down and to the right first. So 1 times 1 times 1 is 1. 6 times 1 times 3 is 18. And 1 times 7 is 7, times negative 1 is negative 7. And we are adding all of these together. 1 plus 18 is 19. 19 minus 7 is 12. Then you're going to do it with your diagonals that go to the left, down and to the left. So 1 times 3. 1 times 1 is 1, times 3 is 3. 1 times 1 is 1, times negative 1 is negative 1. And 6 times 7 is 42, times 1 is still 42. So we're just multiplying all three of the numbers together that are in each diagonal. And that answer is going to get subtracted from the 12. So it's going to be 12 minus 3 minus 1 is 2, plus 42 is 44. And 12 minus 44 is negative 32. So then the area is going to be negative 1/2 times negative 32, which is 16. And then over here for example 2, we're going to do the same thing, but it already gives us the points. So we're going to go straight to the matrix, which is plus or minus 1/2 And we're going to fill in the matrix. -7, -5, -2, 8, 6, -2. And then your third column of all ones, like that. Then, same deal as last time, copy the first column, copy the second column, so that we have our diagonals set up. And we're going to do the right diagonals first. -7 times 8 is -56, times 1 is still -56. -5 times 1 is -5, times 6 is -30. 1 times -2 is -2, times -2 again is +4. -56 minus 30 is -86. -86 plus 4 is -82. Then we're going to do our diagonals that start in the middle and go to the left. So 1 times 8 is 8, times 6 is 48. -7 times 1 is -7, times -2 is +14. And 1 times -2 is -2, times -5 is 10. And then 48 plus 14, 62 plus 10 is 72. So we're going to do -82 minus 72, which is -154. And then our area is going to be -1/2 times this, so the two negatives will cancel out. And -1/2 times -154 is 78. Okay. And then we're going to talk about how to solve systems using determinants too. So for that, we're going to do it in a little bit weirder order. This one is easier to solve, but a little more difficult to understand. So basically, I can find the value of x for a system and the value of y for a system by doing the following. For x, you're going to find the determinant if you cover up the x's. So you have b and the c, whatever numbers are in front of y, whatever your answers are. So basically, no x's on the top. And then for the y's on the top, you're going to cover up the y's, so you only have a and c left, like that. So whatever variable you're looking for, you're skipping that column. And then D, this thing that we're dividing both of these by, is the determinant of just the coefficients. So only the things with the x and the y, we're covering up the answer. Basically, instead of adding a column or a row of all ones, you're picking 2x2s by covering up one of the columns instead. It makes a lot more sense once you see it done though, so I'm going to jump into the first one to kind of explain how this works. So the first thing you need to do is turn the system into a matrix. Okay. And then I'm going to go find x first. So x is going to be, and we're going to write the determinant without the first column of the x coefficients. So just these two. So -5, 22, 7, -6. Oops, I meant for that to be a determinant line. I'll make the other one match. There you go. And then we're going to divide that by the determinant of, if I skip and do just the coefficients, that's what D is. So that's 3, negative 5, 2, 7. Okay, and then for a 2 by 2, remember that we're going to multiply kind of the same way we just did, but there's only one diagonal. So this one, which is 30, minus this diagonal, which is 22 times 7, 154, over the determinant of this one is 21, 3 times 7, minus 2 times negative 5 is negative 10. And since that's a double negative and a minus, I'm going to put that as a plus. So I end up with 30 minus 154, which is negative 124, over 21 plus 10 is 31. And guess what? Negative 124 divided by 31 is negative 4. So I've gotten x equals negative 4 so far. Now you might be like, oh, Mrs. McFadden, we're running out of room already. Yeah, we are, but guess what? For the y value, you already know what's supposed to go on the bottom because they both have the same denominator. So I can already assume that the bottom part is going to be 31. And then all I need to do on the top is write the matrix without the y column. So 3, 22, 2, negative 6. Which is going to be negative 18 minus 2 times 22, 44, over 31. And I'm just going to do this part in a calculator to show you. Okay, 1 second. Negative 18 minus 44 divided by 31 is negative 2. So y is negative 2. Okay, last example. We're going to make it to a matrix. 3, 10, 68, 7, negative 2, 32. And then for the x, skip the x column. So 10, 68, negative 2, 32. And on the bottom, cover up the answer part. So 3, 10, 7, negative 2. Okay, and then on the top, we're going to do the first diagonal. So 10 times 32 is 320, minus negative 2 times 68 is negative 136. And since that's a double negative, that turns into addition, over negative 6 minus 70. Okay, and then I'm going to do this addition in my calculator. 320 plus 136 is 456. Negative 6 minus 70 is negative 76. So 456 divided by negative 76 is negative 6. So that's our x value. And then for our y, we're going to cover up the y column. So it's going to be 3, 68, 7, 32. Over negative 6 minus 70 was negative 76. So then I just really need to do the top part. keep the bottom part as negative 76. 3 times 32 is 96. There we go. And 7 times 68 is 476. And 96 minus 476. This is negative 380 divided by negative 76 is 5. So we have x equals negative 6, y equals 5. And we just solved those equations. So basically, this is replacing all of the elimination and everything.